Okay, we'll get started. Hey everyone, I'm Dhvani. This is Mann, Curtis, Eric, and Tyler, and we're Team Nautilus. We'll first briefly recap our vision and the problem we're solving. Then we'll go over our progress since the midterm demo, some new challenges we face, and our plans going forward. So to recap on our vision and the problem, we presented the knowledge and skills analogy during the last demo, and we essentially want to generalize Grammarly in this diagram for skills other than writing, so replacing Grammarly with Nautilus. Our aim for Symposium Day is to build this platform where experts can go in, add their own heuristics using a no-code interface, and users can use them to receive auto-generated feedback on the current execution of the skill. Now, since the scope of this is quite large, we first narrowed this down to just one domain, which is resume writing. And so for resume writing, students in first and second year always are looking to improve their resume, but don't know how to. And we were once in their shoes as well. Looking back at what we did in our earlier years, we would take the advice of upper years and then know the heuristics to use for improving one's resume. So for example, one should not use first person as in sped up our engine and instead use third person saying sped up the engine. So we're currently working on creating an app where users can upload their resumes and get feedback on how to improve the structure, content, and style of it.
So now for a recap of the architecture. This diagram is a high-level breakdown of how our core service generates feedback. Raw unparsed text, so the resume bullet points, are passed from the API to the core engine. Then we leverage NLP libraries such as Spacy to represent the text as a parse tree. And now we can run custom tasks and heuristics on this parse tree, which generate feedback and suggestions that we're going to send back to the client. Since the midterm demos, we've made some slight tweaks to the architecture of our app. So we replaced Django with Spacy. We replaced Django with Flask as our API framework. We replaced Stanza with Spacy as our language model. And we introduced CI/CD flows to automatically deploy the front-end, back-end, and core changes to prod after we've merged to main. If you have any specific questions about these components, feel free to ask at the end of the presentation.
Since the midterm demos, we improved the app's user experience and increased the number of checks from 3 to 14. We've added notable checks recognizing duplicated nouns, redundant action verbs, contrived phrases, obscure acronyms, and improper tenses. We now also recommend users to be specific with their metrics. So to convey the rationale behind each surface feedback, we now categorize each feedback into 3 types: wording, white space, simplicity, and tone. Sorry, 4 types. From a backend infrastructure perspective, we introduce tests and offload most of computations onto a local language server to speed up check development. From a performance point of view, we improve the speed of our text parsing so that users can analyze their text nearly instantaneously. Previously, users would have to wait up to 15 seconds to parse a single bullet point. In contrast, we can now parse our entire resume in under 5 seconds. Lastly, we started creating a corpus of action verbs to provide better suggestions. This corpus and others like it will deliver handpicked suggestions that will outperform our ML models' generated suggestions. Overall, we improved our system's robustness, improved the code quality, and established firm foundations to develop future features.
Next, we overhauled the front-end design and functionality to make the UX be a polished product. We basically restructured the overall layout of the app and separated the 2 columns into 2 different scrollable components. So one for resume feedback and one for all suggestions. But to give you a better understanding of the changes, let's jump into an actual demo. So this is our site that's live. Given the massive performance improvements that Curtis mentioned, we now allow the user to get feedback as they type. So for example, as I'm typing, you can see that suggestions get generated and all options appear on the right as clickable, animated, scrollable components. So for example, once I click this, it'll expand and also highlight welcome. And the different feedback is underlined and highlighted. So we also added some different admin functionalities. So first we have access codes that's mainly for user tracking, analytics, and Mixpanel. But also if we add admin, we now have like examples that can get selected. So for example, we can just go ahead and select one of the examples and we see that the text immediately gets analyzed and we have a lot of suggestions that are generated. So for example, we can open suggestions using capital, but also if we go ahead and actually open it through the text, we can see that the cards get opened and or basically that card gets focused. So for example, just to get more suggestions generated, we can copy the text twice. And we can see that the same suggestions are basically going to get generated twice. So we might have 1 hour here and another here. And one other feature we added was having sorting. So right now the suggestions are generated sorted based on relevance. So that's why you can see that the two R cards are right beside each other. But if we go and sort by text order instead, we can see that the cards have all changed. And so if we click this hour, the card is here. But if we go down, it'll scroll to the other hour. And one other feature we added is you might notice that, for example, some cards have suggestion text to replace the text. So for example, with April, we should abbreviate April to be APR instead, since it's still intuitive what the word is. So if we click the actual suggestion text, we can see that now the text displayed gets updated and that card's removed. But still everything else remains the same. So that's a general overview of our actual app. We can go back to the presentation.
Our goal since the previous demo was to conduct 20 user interviews in order to collect feedback. We did not successfully reach this goal because we made the decision to pivot after a few of our initial interviews. In total, we were able to conduct 11 interviews. The first few interviews conducted provided us with valuable feedback. This included UX UI issues we had, such as confusing highlighting, lack of ability to sort, lack of ability to filter suggestions, and how it's not very clear you can click open suggestions initially. Also, it provided us with ideas of future features that people desire, such as being able to upload a PDF of the resume, as well as better suggestion search / filtering by categories. We did learn insights such as the reason why people chose specific bullet points and also value of the suggestions generated. We were able to meet our goal of generating 5 suggestions per click and having 2 suggestions out of those being accepted. In fact, the percentage of suggestions generated was high due to many false positives. After removing the account of false positives, about 45% of suggestions were accepted, exceeding our goal for number of suggestions that were accepted. We decided to postpone interviewing more people until we make the changes to address the additional feedback that we received. We felt that it wouldn't really be useful to interview more people with the current product as the
I think Eric might be having connection issues, but I'll just finish up
as of yet.
Yeah, I think Eric, you just cut off at the end. So can you just repeat the last bullet point?
Sorry, I think my Wi-Fi is pretty bad, but
no worries.
Yeah, we also didn't really publicly share our link due to the feedback we received from our focus group, and thus we don't really have an idea of like the conversion rate from the app being open to the app being used yet.
So one of the challenges we faced was performance, and as previously mentioned, we were able to make major improvements in this area. So some initial testing of our POC revealed that analysis was taking around 15 seconds for a bullet. And as we increase the body of text, what we expect from a longer sort of multi-page resume, we noticed was sort of like an upper bound of 45 seconds or even longer for generating all the feedback. So to improve this, we decided we needed to profile our solution to identify the areas where most of the computation was being done. And the first finding from this step is that parsing is expensive. So for a typical request, we were seeing that about half the time was spent in the parsing, and then the other half was spent in the analysis and generation of the feedback. So we decided to look into some parsing alternatives, and we eventually settled on the Spacey language model. This actually gave us 2 benefits. The first of which was that we got more accurate parsing because the Spacey model has hooks where we can define some custom logic. And additionally, we also got drastically better performance down to actually within a second because the Spacey model avoids a lot of additional looping and recognition of the input that we didn't need for our particular purpose. After that, we turned our attention to the engine within Core that actually performs the analysis and generates the feedback. So heuristics are defined in a set of YAML files, and we then take those YAML files and turn them into directed acyclic graphs for computation. So each user request that the Core module was receiving involved rereading those YAML files and then reconstructing the DAGs, which involved more type checking and other business logic validation before the user input would actually be run on them. So we replaced this implementation by parsing the YAML files once during startup, and then we would create generators for the DAGs and the feedback. So now each user request would simply use these template objects, and we avoided the need for expensive parsing and expensive validation as precursors. As part of this refactor, we also modularized components so that we can easily enable concurrent execution if we need to for the future.
So another significant challenge was accurately parsing our text. When we switched to using Spacey, we recognized I had difficulty performing sentence segmentation. Since Spacey was not designed to parse resumes, its algorithms struggled to identify sentence boundaries. So without proper sentence boundaries, most of our checks didn't return or it returned false positives. To solve this problem, we wrote a custom sentence splitter that was tailor-made for the resume parsing task, and this yielded extremely accurate parsing.
Another issue we faced was how our production environment kept breaking due to pull requests being merged in, causing us to have to invest more time to debug issues. The reason for these issues were often due to one PR that has some sort of refactoring that impacted another area of code that the user who made a PR did not test themselves manually. Thus, we decided to take the time to invest into integrating tests for tasks for the engine using PyTest. We added running these tests in the GitHub workflow whenever a pull request is open against main. Thus, if proposed changes cause a test failure, it will prohibit the pull request from being merged. Since we introduced this, it has significantly improved our development time since we don't have to spend time debugging issues on product. The next step is to add tests for the front end as well.
Moving forward to the next steps for our capstone in general, one key thing is implementing actual feedback we got from users. So we got a lot of useful feedback based on our UX behavior and general structure. So one of the main ones is being able to upload resumes as a PDF or a doc file. And the reason why is it's very inconvenient for users to actually copy and paste their resume, and it might mess up their formatting. So being able to actually upload the files would be a lot more useful, as well as having more clarity on some upper functionality. Like right now, we still have the analyze text button, but it's a bit redundant since we now analyze on type. So having just a loading indicator might be better. And initially having more clarity and functionality on the sorting buttons. So we could expand this to actually have filtering and sorting. That, for example, we can search for a specific category and then only display those suggestions that get generated.
Okay, yeah. And then in terms of like actual testing and more user testing, that our plan for the next, so this semester we sort of built a lot of the general building blocks for the general platform for feedback on text. And we're at a good stage to test the resume feedback. So we're going to be doing a lot more resume user testing in the fall term. And then to support our soft launch, where we share the link publicly, we've added a mixed panel to track product analytics. And so the hope is to collect statistics on how users are using our product and if we're reaching our metric goals or not. It'll also give us an indication of a workflow so we can know without talking to our users if there's certain UX or UI issues. We also created a dev deployment in addition to the prod deployment, so we can separate dev features onto a dev branch. That way, once we are soft launch, prod is not breaking and it's actually causing impact on users. Over the fall term, before SC491, we're also planning on exploring other applications where experts can code rules for text feedback that is not resumes. This will allow us to get feedback on the no-code portion if we can find a good application. And then it will also give us a better defined roadmap for 491 for the general platform.
So we have a plan for supporting this general platform from a tech point of view. So one, we want to define a library of generic tasks, things like filter and replace and find. This allows users to easily define heuristics without needing additional task implementations. Currently, tasks are more one-off specialized units of functionality. So we want to create a rich library that lets users really compose their own heuristics from them easily. Two, we want to support bounded loops in heuristic definitions so that we can specify more powerful graphs without needing users to sort of define the same task multiple times in a pipeline and without needing to write custom functions. And third, we want to extend the API request and response types to contain metadata information so that the engine can determine which heuristic it needs to run on this particular input. And that's it. Thanks for listening. See you in 491, and I'm opening the floor to any questions.
I'm going to stop the recording now.